A TBI is sort of short, sometimes doctor speak, for traumatic brain injury. And it is a large umbrella term that encompasses so many different types of injuries to the brain. For example, we've all heard the word concussion. And in fact, there's a movie that Will Smith made very famous about this issue. A concussion is, by definition, a mild traumatic brain injury. It is a disruption into the neural pathways. It could be something that causes a chemical reaction in the brain. For a long time, people would look at a brain injury and only classify it as such if it were a penetrating injury, such as a puncture wound or a fractured skull, something that you could see easier. And then years and years ago, there were terms that were not very well understood that were used in the context of warfighting. Shell-shocked was a term that was used years and decades ago, which referred to a combination typically of PTSD and maybe some sort of brain injury related to an explosion. And so as science has progressed, and thankfully as litigation has progressed, you've seen that a lot of these concepts are more prevalent today in the news. You hear about them more for a couple of reasons. One, the science is there because it can recognize the significance of the injuries and the fact that an injury doesn't have to be some huge debilitating impact. It doesn't have to be a huge debilitating blow that is instantly fatal. It can be a series of smaller impacts, such as you see in repetitive sports injuries. It can be a milder impact in a car wreck. And in some cases, you can have a traumatic brain injury even if you don't have an impact to the head. You can have a whiplash type sloshing of the brain, because if you'll think about it, the brain is encased in a heavy-duty brain case, but inside that skull, you've got movement of the brain, just like you have with your organs in your body. And so if you have a rapid acceleration and deceleration of your brain, a good example of this is if you think of an airplane, okay? And an aircraft that comes in from flight and touches down and comes to a stop, it goes from 200 miles an hour to 0. And if everything goes right, no one gets hurt. And it's because that period of time that it goes from the 200 miles an hour to 0 is spread out over a long period of time, seconds, okay, sometimes a minute. And if you graphed it, it would be this long sort of sloping curve. And that allows the body, the tolerances of the human body, to ride that down, to absorb some of those deceleration forces, and you're within the limits of what the human body can tolerate. Sometimes it's called a crash pulse. Sometimes it's referred to as the delta V, which is the change in velocity over time, okay? Well, if you look then and apply that same concept to a car wreck or an impact on the football field, then you've got, again, you're going from a speed, whether that be a 40-mile-an-hour car wreck, whether that be a 15-mile-an-hour sprint, whatever it is, to a stop. The difference here is, how long does it take? And so if a car comes up to a red light and is going 40 miles an hour, steps on the brake, comes to a stop, everybody's fine. It comes to the same red light, it doesn't stop and hits a car and comes to a stop immediately. That overrides the tolerances that the human body can accept to reduce that speed. And so then you start to see things like shearing and diffuse axonal injuries in the brain. You have, if you remember from school, they talked about where nerves would speak to each other. You'd have a synapse, basically. And you'd have axons and dendrites that would talk to each other, and there's a little synapse there. Well, shearing forces that acceleration and sudden deceleration can actually tear some of those connections apart in the brain on the microscopic level. And so you might not even see them if you looked at them with your open eye, but you begin to develop little microscopic tears when you have this sudden stop. And you know, it's like everything else. There is a level past which the body can't tolerate that sort of deceleration trauma. And so, yeah, you do see traumatic brain injuries in the news a lot right now. It's been popularized in the movies. It's talked about a lot on the news. And some of that, a large part of that, thankfully, comes from litigation efforts and the fact that football helmets, you know, can and should be safer. The NFL has been under fire for a number of years now and increasing recently because of its knowledge of concussion-related injuries. And football impacts that over time will build up this concussive syndrome. It has to do with the creation of a tau, T-A-U protein that builds up in the brain and can create and mimic, in some respects, Alzheimer's type symptoms early on. It's a very progressive disease, and it's awful to the family and to the sufferer, and is debilitating as it progresses. So, you know, you see traumatic brain injuries in so many instances. You see that they can happen in so many different ways. And our goal, again, as always, is to try to prevent that from happening through holding companies accountable.